Welcome to all students. Today I am starting my lecture on network analysis and synthesis. The first topic is basic circuital law. So these are some basic definitions related to a circuit. This is a circuit where this is resistance R1, R2, R3, R4, R5, R6 and R7. These 2 points are called nodes, and when we joined line between and a element between two nodes, that is called branch. So the first definition is node. Any point where two or more circuit elements are connected together are called nodes. This point and this point. Any point where two or more circuit elements. These circuit elements are connected on this node. These circuit elements are connected on this node. These circuit elements are connected on this node. Therefore, this point is called node. Okay, wires usually have negligible resistance. Each node has one voltage with respect to the ground. The second definition is branch. This is a circuit element between two nodes that is called branch. Means this is one node and this is two node. Between these two nodes, one element exists. This and this is called branch. Third one is loop, a collection of branches that form a closed path returning to the same node without going through any other nodes or branches twice. Means the collection of branches which form a closed path. This is a branch, this is another branch, they are forming a loop like this, and this is called loop. Now next is Kirchhoff's first law. Kirchhoff's first law is known as KCL, that is the Kirchhoff's current law. It states that the total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, the algebraic sum of all the currents entering and leaving a node must be equal to 0. Means I existing or I outgoing plus I entering should be equal to the 0. This idea by Kirchhoff is commonly known as the conservation of charge. So basically, what is KCL? KCL means this is the node, this current I1, I2 and I3. This is incoming current, and the arrow direction shows I4 and I5. This is outgoing current. Means the summation of all currents at this node should be equal to the 0. Here I1, I2 and I3 are incoming current and I4 and I5 are outgoing current. So we will take this I4 and I5 in negative form and I1 and I2 in I3. So summation of all these currents should be equal to the 0. Means I1 plus I2 plus I3 minus I4 minus I5 should be equal to the 0. This is known as the KCL. Here the three currents entering the node I1, I2, I3 are all positive in value, and the two currents leaving the node I4 and I5 are negative in value. Then this means we can also rewrite this equation as this: I1 plus I2 plus I3 minus I4, I5, that should be equal to the 0, as we discussed earlier. Next is Kirchhoff's second law. That is known as the KVL, also known as the Kirchhoff's voltage law. It states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is also equal to the 0. Means, in other words, the algebraic sum of all voltages within the loop must be equal to the 0. This idea by Kirchhoff is known as the conservation of energy. So according to Kirchhoff's second law, or we can say Kirchhoff's voltage law, summation of all voltage drops should be equal to the 0. Means the sum of all voltage drops around the loop is equal to the 0. In mathematical term, we can say VAB plus VBC plus VCD plus VDA should be equal to the 0. So this is known as the Kirchhoff's second law, or we can say Kirchhoff's voltage law. In this lectures, we studied what is node, what is branch, and the definition of a loop, and two basic circuit law. These two basic circuit law are known as KVL, that is the Kirchhoff's voltage law, and KCL, that is the Kirchhoff's current law. Thank you.